So this one says the following. We're integrating over R. So again, R means, that indicates that our domain is a rectangle, which is good, because that means it's simpler. To Y, and we have dA. Okay, so, and they also give us the rectangle dimensions. So this will be 0 to pi over 2 times 0 to pi over 2. So this is actually a square, okay? And this corresponds to x, and this corresponds to y. All right? So what we have is 0 to pi over 2, 0 to pi over 2. And then our f of xy just stays the same. Sine 2y. And these can actually go in either order, right? Because both the intervals for x and y are the same. So I'll just write dx dy. You could likewise write dy dx. Okay, so also what's important to recognize here is that we have two kind of separate functions, right? One is a function only of x, and the other is a function only of y. And furthermore, which is also necessary, they're being multiplied together. Okay, if these were added together, that technically binds them together into a complete f of x comma y, in which case you can't separate it into two separate integrals. But in this case, you can, because they're being multiplied. The same holds true for when you're dividing things. Let's say you were to have like x over y. That's the same thing as x times y to the negative 1. So you could also use it here as well. So anytime you see something multiplied or divided, that's good. But added or subtracted, that kind of messes things up. So anyways, what I'm going to do here is break it up, put all the x's in one group of parentheses, and all the y's in the other. Okay? So let's find x stuff. So x stuff is in the inner one. That's what I made it. So we have 0 to pi over 2, and then this is our g of x, our function only of x, and then our dx. So then we have the leftovers, the y's, right? The y is all the outer stuff. So those bounds and the y function, which is sine of 2y, and then our dy. All right? So let's evaluate these separately, and then at the end we'll multiply them to get our final answer. So the first one here, 0 to pi over 2, that's cosine x dx. So this becomes a sine x, and that's from x equals 0 to x equals pi over 2. This is sine pi over 2 minus sine 0, and as we solved previously, this is just going to be 1. Okay, so this is going to be a 1, and now our concern is to solve for the second set of parentheses, which is sine 2y dy. Okay, so here we see that a u substitution will come in handy. So we make our u be 2y, this part, and our du is then, we just take the derivative, so 2 dy, and then what I like to do is get dy by itself, so I can just substitute it in directly. So dy by itself is divide the 2 over, so we get du over 2. Okay, these are kind of like mini equations, and as the name says, u substitution, we're just getting things in terms of a different variable, so we can substitute it in, do some calculus, and then substitute our original variable, which in this case is y. Yeah, so the final step is substituting y's back in, and then solving the rest. So this is kind of like an intermediary step, just something that we go through. Okay, so let's get things in terms of u's. And when we switch into the u's, I like to remove the bounds, like the 0 and the pi over 2, entirely, because technically if you write them in when you're doing u's, it's incorrect, because we're going into a different set of variables or whatever. So anyways, I just refrain from putting the bounds in. But anyways, so we have sine of 2y is now u, and then dy is now du over 2. Okay, so as you can see here, aside from the 1 over 2, the factor of 1 over 2 that came in, we have everything in terms of u's, all right? So this is like 1/2 integral of sine u du. So now we can evaluate this as an indefinite integral because it doesn't have bounds, right? So when we do this, then we get negative cosine u, right? And then like a plus c, but I'll just hold off on the plus c for now because we do have a definite integral with these bounds. So at this point, now that I transitioned from the integral and I actually integrated, then I'm going to switch back into y form. So switch back to y's. Now I'm just explaining it here because some people might not have gone over this method in high school or in earlier math classes. So anyways, what this is going to turn out to be is a negative 1/2 cosine, and now we have a 2y because we're putting this equation, we're making use of this equation and just doing it backwards. Okay? And now that we put the y's back in, we can put in the interval once again because y is going from 0 to pi over 2. All right, so this is where we're leaving off, and I'll go on to the next step in the next slide. All right, so when we plug in, we get cosine of 2 times pi over 2 minus a negative 1 over 2 times cosine of 2 times 0. Okay, a lot of parentheses going on here. Okay, and what this turns out to be is negative 1/2 cosine pi plus a 1/2 cosine 0, which equals negative 1/2 times negative 1 plus 1/2 times 1, which is a 1/2 plus a 1/2, which equals 1. Okay? So that is our final answer for that problem. All right? So that just about wraps it up for this video. I hope that helped with your homework problems and such. Okay, I'll talk to you in the next video. Hope you watch.